Welcome to another deep dive into the source material. We are so glad to have you, our resident learner, with us today, because today we are taking on a massive topic.
Huge topic.
Yeah, we are looking at a really comprehensive stack of historical records, letters, and scientific transcripts about the life of someone you definitely know, Albert Einstein.
Right.
But our mission today is to entirely strip away the myth. We want to dismantle this image of Einstein as this, untouchable, preordained genius who just woke up one day with all the answers to the universe.
Which is how he's usually portrayed.
Exactly.
Yeah.
Instead, we're going to explore a grueling, error-filled, 15-year human struggle just to prove his general theory of relativity.
And that is really the core of what we distilled for you today. When you look closely at these records, what really stands out is that this isn't just a science story.
No, not at all.
It is a deeply human story. I mean, It involves global war, bitter academic rivalries, an incredible amount of isolation, and immense personal sacrifice. It's a raw look at how messy the process of discovery actually is.
Okay, let's unpack this by asking you to imagine a scenario. Imagine you're sitting at home, you hear a knock, you open your front door, and standing there on your porch trying to sell you life insurance is Albert Einstein.
It sounds absurd, but in the early 1900s, that was a very real possibility.
Yeah.
Albert Einstein was a 21-year-old undergraduate at the Swiss Federal Polytechnic, and frankly, none of his professors thought he was anything special.
He was known for cutting class.
He was. They viewed him as a lazy goof-off.
And the consequences of that reputation were severe. When he graduated, he couldn't get a single academic job. He was constantly getting rejected by colleges and high schools. His father actually passed away believing that young Albert was a complete disgrace to the family.
That's rough.
It is. Einstein felt like such a failure that he wrote a letter to his family saying it might have been better if he had never been born. He seriously considered giving up physics entirely to sell insurance.
It's a staggering contrast to the icon we know today. But in 1902, a depressed Einstein moved to Bern, Switzerland, where a friend helped him get a job as a lowly third-class clerk at the Swiss Patent Office.
And as it turns out, that rejection from the academic world was perhaps the greatest blessing in disguise he could have asked for.
Oh, absolutely.
I mean, it sounds like a demotion, but working in that patent office was essentially a masterclass in distillation. He spent 6 days a week reviewing technical applications from inventors.
Right, sorting machines, electrical synchronizers.
Exactly. And his daily job was to take all this complex, convoluted information and strip it down to its absolute essence. That daily practice fundamentally honed his skills as a theoretical physicist.
Precisely. And because he became so incredibly efficient at stripping down these concepts, he had ample free time at his desk. He didn't have to kiss up to university professors or worry about publishing quotas. He could just sit on a stool and daydream.
Which he called thought experiments.
Right, his thought experiments.
And those thought experiments led directly to 1905, which historians refer to as his miracle year. In his spare time, outside of his 6-day-a-week desk job, this 26-year-old unknown clerk published 4 visionary papers that completely changed our understanding of reality.
It's unbelievable.
Let's space these out, because doing just one of these in a lifetime would guarantee you a place in history. First, he explained the photoelectric effect, proving that light comes in little packets of energy called photons.
Which is the foundational science we now use for television screens, digital cameras, lasers.
Yeah. Then, in his second paper, he proved the actual physical existence of atoms. At the time, many prominent scientists still thought atoms were just a convenient mathematical concept, not real physical objects.
Right, they thought it was just a useful model.
But Einstein proved they were real by mathematically showing how invisible atoms randomly collide with small dust particles to make them jitter in a liquid, a phenomenon known as Brownian motion.
And if that wasn't enough, his third paper introduced E = mc squared.
Just casually dropping that in.
Yeah, he mathematically showed that matter and energy are two sides of the same coin and can convert into one another. That single equation finally answered the age-old question of why stars shine. The idea of solving the fundamental mechanism of the sun while on a lunch break from a mundane desk job is just wild to think about.
And then comes the fourth paper, the special theory of relativity.
The big one.
The origin of this one is incredible. It all came from one of those visual thought experiments. Einstein was riding a bus in Bern, and he looked back at the famous clock tower in the center of the city. He imagined what would happen if that bus suddenly accelerated to the speed of light.
Right.
In his mind's eye, he realized that as he reached the speed of light, the light bouncing off the clock face could no longer catch up to him. The hands of the clock would appear completely frozen in time. But back at the tower, time would be passing normally.
So time is not absolute.
Exactly. Time slows down depending on how fast you're moving. This insight meant that space and time are deeply, inextricably connected. They are one flexible fabric, which we now call space-time.
What's fascinating here is that he was a complete outsider. He wasn't a recognized scientist, he was a bureaucrat. He writes these radical ideas down, submits them to Europe's most prestigious scientific journals, and is met with complete silence for months.
Crickets.
Complete crickets. But eventually, his paper caught the eye of Max Planck in Berlin. Planck was the editor of the most important physics journal at the time, and arguably the greatest theoretical physicist in Europe. Planck read this paper from an unknown patent clerk and immediately recognized its brilliance, slowly bringing Einstein into the academic fold.
But the work was far from finished. We jump forward to 1907. Einstein realizes his special theory of relativity has a massive defect. It only works for a special case. Objects moving at a constant speed in a straight line.
Hence the name special relativity.
Right. But in the real universe, everything accelerates.
Yeah.
Jet airplanes, subway cars, planets on a bumpy elliptical road through space, they all change speed. And more importantly, the theory completely left out gravity.
And to solve the problem of gravity, Einstein knew he had to take on his ultimate scientific hero, Sir Isaac Newton.
Which is a big deal.
A massive deal. For 2.5 centuries, Newton's word was basically the word of God in physics. Newton said gravity was a mysterious pulling force acting across vast distances. But even Newton didn't really know what was doing the pulling. Einstein decided that wasn't good enough.
So he goes back to his thought experiments. He's looking out his patent office window, and he imagines a man falling off a roof.
He later called this the happiest thought of his life. He realized that a man falling off a roof wouldn't feel his own weight. He'd be weightless. If you are in an elevator and the cord is cut, you fall, but the elevator falls at the exact same rate you do, so you float inside it. Falling and floating in zero gravity feel exactly the same.
Einstein realized that if falling feels exactly the same as floating, then maybe gravity isn't a magnetic-like pull at all. Instead of the Earth pulling you down, what if the Earth is sagging into the invisible fabric of space, like a heavy bowling ball sitting on a trampoline?
You aren't being pulled. You are just sliding down the slope created by that massive object.
Exactly. Massive objects curve the fabric of space-time around them. Space itself is malleable, the sun has warped the space around it, and that curved space is actually pushing the Earth into its orbit.
By 1913, his reputation in academic circles is growing, and the establishment comes calling. Max Planck and Walther Nernst, two absolute titans of German science, travel to Zurich train station to personally recruit Einstein for a top, highly paid position in Berlin.
It's like something out of a movie. Einstein, ever the unconventional thinker, tells these two eminent scientists to go take a hike up the mountain for the afternoon while he thinks about it. He tells them to meet him back at the train station later. If he's holding red flowers, he'll take the job and move to Germany. If he's holding white flowers, the answer is no.
Talk about drama.
I know. They come back, and he's holding the red flowers. So he moves to Berlin. But his personal life at this point is incredibly strained.
Yes, the move to Berlin was a breaking point for his marriage. He leaves behind his wife, Mileva, who was the only woman in his physics class at the Polytechnic and a vital sounding board for his 1905 papers, and their 2 young sons.
Right.
He had reconnected with his cousin Elsa, who lived in Berlin. Einstein presented Mileva with a highly restrictive marital contract. It included demands like, "You must bring me my meals in my room, and you are not to expect intimacies from me." Mileva refused to sign it, gathered their boys, and eventually moved back to Switzerland.
The timing of his move to Berlin is also critical. It's early 1914, right as World War I breaks out. When you look at his colleagues during the outbreak of the war, there's a chilling contrast. This created a profound ideological split in the scientific community.
Absolutely. His close friend and colleague, the brilliant chemist Fritz Haber, enthusiastically supports the German war effort. Haber views his scientific knowledge as a tool for the state, and he feels he can end the war quickly and humanely by developing a devastating new weapon.
Which was?
He creates poison chlorine gas for the military and personally oversees its release on a Belgian battlefield, resulting in thousands of casualties in the trenches.
Einstein views this as a gross misuse of scientific progress. He calls this kind of technological application an axe in the hands of a madman. He refuses to sign a manifesto supporting the war, which nearly all his colleagues, including Haber, eagerly signed. Einstein becomes a staunch pacifist, which leaves him completely isolated in Berlin.
Surrounded by a world tearing itself apart with military technology, Einstein completely withdraws. His only escape is his mind. The city is starving under a blockade, his marriage has fallen apart, and he retreats into his study. He plays his violin to help him visualize the harmonies of the universe, and he pulls out his old calculations for gravity to find solace.
Here's where it gets really interesting. Instead of comfort, he finds a glaring error. He realizes his math for general relativity is wrong. And not only is his math wrong, but he is suddenly in a neck-and-neck race with David Hilbert.
Oh, wow.
Yeah, Hilbert was one of the greatest mathematicians of the era. He had heard Einstein give a lecture in Göttingen, realized Einstein's math was clunky, and decided he could solve the gravitation equations himself.
This is a nightmare scenario for Einstein. He relied heavily on physical intuition, but general relativity required rigorous, incredibly complex tensor calculus, which was Hilbert's exact specialty. Einstein is working to the point of exhaustion, experiencing severe stomach issues, terrified he'll be steeped on his own life's work.
It's a furious exchange of postcards and letters between the two men, each racing to unlock the secret of gravity. After years of dead ends, trial and error, and throwing his notebooks in disgust, Einstein looks at an old astronomical riddle.
Right, the orbit of Mercury.
Exactly. For generations, astronomers knew the planet Mercury didn't orbit the sun exactly as Newton's laws predicted. Its orbit tilts slightly, drawing a pattern like the petals of a flower over time. In late 1915, Einstein applies his newly corrected equations for curved spacetime to Mercury, and it's a perfect match. The math works perfectly.
Incredible.
He later wrote that he had heart palpitations. He's so filled with joy his brain can hardly focus. He beats Hilbert to the punch and presents his finalized general theory of relativity to the Prussian Academy.
But there's a catch. A mathematical equation on a chalkboard isn't enough to overturn 250 years of Newtonian physics. Einstein needed physical, real-world proof. He needed astronomers to test his theory.
And the only way to prove that massive objects curve space is to look at starlight passing right next to the sun. If space is curved like a trampoline, the beam of light from a distant star will actually appear to bend as it travels through that warped space toward Earth.
But you can't see stars next to the sun during the day because the sun is too bright.
Right.
The only time you can see this is during a total solar eclipse, when the moon completely blocks the sun and the stars suddenly become visible in the middle of the day. So begins the global quest for proof.
Which was not easy.
No. Strike one happens in 1914. A young German astronomer named Erwin Finley Freundlich and a rugged American pioneer of eclipse photography named William Wallace Campbell set up camps in the Crimea, in Russia, to photograph an eclipse. But World War I breaks out just days before the event. The Russians arrest Freundlich as an enemy combatant and confiscate his gear.
And
Campbell, the American, is allowed to stay, but a massive storm rolls in, the sky clouds over, and he misses the eclipse entirely. He has to abandon his state-of-the-art equipment and go home defeated.
That sounds like a disaster for Einstein.
You'd think so. But if we connect this to the bigger picture, that failure was actually incredibly fortunate. Remember, in 1914, Einstein's math was still wrong. He didn't fix his equations until late 1915 during his race with Hilbert.
Right.
If Freundlich and Campbell had managed to take those photos in 1914, the deflection of light would have only been half of what Einstein predicted. It would have completely discredited his theory on the global stage. The outbreak of World War I, in a strange twist of fate, actually saved general relativity.
Wow. Okay, so strike two is in 1918. Campbell tries again, this time in Washington State. His good equipment is still trapped in Russia, so he cobbles together makeshift cameras using spare lenses and tubes. The clouds part at the last second, and he gets the photos.
Finally.
He has his assistant, Heber D. Curtis, spend agonizing months looking through a micrometer, checking the crosshairs on these glass plates to measure the stars. And Curtis finds nothing.
Nothing.
The stars haven't moved. The theory looks completely wrong.
Yeah.
Campbell sends a 5-word telegram to his colleagues. Delay publishing Einstein results, Campbell. He isn't ready to stake his hard-earned reputation on cobbled-together equipment.
Which brings us to strike three, 1919. Enter Arthur Eddington, the head of the Cambridge Observatory in England. Eddington is a brilliant astronomer, but he's also a deeply religious Quaker and a pacifist. During the war, his fellow Quakers were being imprisoned in England for refusing to fight the Germans. When Eddington receives a smuggled copy of Einstein's paper, he sees an opportunity.
He wants an Englishman to prove a German's theory right, immediately after the most devastating war in human history. He sees it as a way to promote international brotherhood through science. So Eddington travels to the remote jungle island of Principe, off the coast of West Africa.
And this expedition is no small feat. It involves weeks of travel, hauling delicate glass photographic plates and heavy brass telescope tubes through a humid, mosquito-infested jungle. He is battling malaria, venomous snakes, and torrential rain. On the day of the eclipse, a massive rainstorm hits. They are standing in the mud, staring at thick clouds. But right as totality approaches, the clouds part just enough.
Just enough.
Eddington frantically swaps out photographic plates, not even looking up at the eclipse himself, and manages to get a few brief exposures.
Then comes the showdown in November 1919 at the Royal Astronomical Society in London. They are meeting under a giant portrait of Sir Isaac Newton. You have Campbell, who had come to London with his negative results from 1918, preparing to defend the Newtonian universe. But then Eddington's results are read to the room.
The tension must have been palpable.
Oh, absolutely. He had painstakingly measured the plates, and the deflection of starlight perfectly verified Einstein's theory of curved spacetime. Eddington literally looks at the painting and says, "Forgive us, Sir Isaac Newton, your universe has been overturned."
The press goes wild. Overnight, Einstein becomes a global superstar. The New York Times, the Times of London, they all run headlines about this peaceful German scientist who has given the world a new truth. But this raises an important question. Was the scientific community actually convinced?
Because of the war.
Exactly. The Allied nations were still incredibly hostile toward Germany. People accused Eddington of being biased, suggesting he fudged the numbers to push his pacifist, pro-peace agenda. The photographic results were essentially a split decision between Campbell's negative data and Eddington's positive data.
So Campbell, seeking total vindication for the scientific method, mounts a massive expedition to Australia in 1922 for another eclipse. This time, he has the absolute Cadillac of measuring equipment. He has crystal clear skies. He photographs 92 stars, and the results are undeniable. The stars shifted exactly as Einstein predicted.
So Campbell resoundingly corroborates Eddington.
He does, and the very first person Campbell cables with the good news is Albert Einstein. He is fully, undeniably vindicated.
And that leads to a truly bizarre twist regarding the Nobel Prize. Einstein had been nominated repeatedly for years, but the Nobel Committee kept rejecting him because relativity was just too controversial and theoretically radical. Like, he finally wins the Nobel Prize in 1922. But the committee explicitly states that the prize is not for the theory of relativity.
Why?
He wins it for his 1905 paper on the photoelectric effect.
Which brings us back to Mileva, his first wife. Years earlier, when Einstein was desperate for a divorce so he could marry Elsa, he made this brazenly confident bet. He told Mileva that if she gave him a divorce, he would give her all the money when he inevitably won the Nobel Prize.
He bet his own children's financial future on a prize he hadn't won for a theory that hadn't even been proven yet.
But she took the bet. And when he finally won, she got the entire payout and used it to buy 3 apartment buildings in Zurich.
It really makes you pause and think about you, the listener. Consider the sheer force of will required to wander in the dark wilderness of a problem for 15 years, to make embarrassing mathematical errors in front of your peers, to face the total isolation of a global war where your closest friends are building weapons, to wait on the weather to cooperate during an eclipse, and through all of that, never giving up on the belief that you are on the verge of fundamentally understanding the universe.
It's an epic journey. From a depressed, rejected patent clerk who thought he was a failure, to the man whose ideas literally birthed the modern age. The lasers in our grocery checkout aisles, the telecommunications satellites orbiting our planet, our entire understanding of black holes and the Big Bang. None of it exists without Albert Einstein's work.
That's entirely true.
So what does this all mean? To me, it means that human intellect, relying on absolutely nothing but a pencil, a notebook, and the power of imagination, those daydreams he called thought experiments, can completely overturn centuries of firmly established truth.
I think that's exactly right. And I want to leave you with one final thought to mull over. We spent all this time talking about Einstein, proving that space-time is malleable. The very fabric of the universe, space and time, can bend, twist, and change based entirely on your perspective, your mass, and your speed. If the physical universe itself is that flexible, what firmly held truths in your own life or your own career might just be an illusion based on your current vantage point. What happens if you sit down, run your own thought experiment, and consciously change your perspective today?
What a fantastic question to leave off on. Thank you to our resident learner for joining us on this deep dive into the source material. We hope it sparks some new ideas for you. Keep asking questions, keep running those thought experiments, and as always, keep looking up at the stars. We'll see you next time.